Welcome back to LangChain Masterclass. In the previous videos, we learned what LangChain is and how to set up our environment with Gemini and Llama models. Now, it's time to dive into the fundamentals of building LLM powered applications. In this episode, we'll cover the core concepts that every LangChain developer must understand: tokens and context windows to understand how LLMs see and process your input, chat models versus base LLMs to understand when to use which and why, prompts with system, user, and AI messages to understand the building blocks of conversations, and structured outputs in JSON mode for predictable and program friendly responses. And by the end of this episode, you'll understand the key mechanics behind LLM apps and be ready to start building structured conversational AI workflows. So let's get started with the first topic: tokens and context windows. Let's start by talking about tokens, one of the most fundamental concepts in working with LLMs. Tokens are essential units of text that the model processes. You can think of them as the building blocks of the input text you give to an LLM. So, a token can be a whole word, it can also be a subword, or even a punctuation mark here. For example, if you take this text hello world, here the tokens are the word hello world and this punctuation mark. That makes a total of 3 tokens. It is important to note that tokens are not the same as characters. One token can include multiple characters depending on how the model's tokenizer splits the text. And understanding token is crucial because LLM processes one token at a time, and things like context, window limits, cost, and response length are all measured in terms of tokens. Now that we understand what tokens are, let's see why they matter. So LLMs process everything in tokens, like I said. That means both your input and the model's output are counted in tokens. And this is important because the cost and the response length are measured in tokens. The longer your input or the longer your response, your request, the more tokens the model uses, which can increase computation cost. Additionally, every model has a maximum number of tokens it can handle at once, known as the context window. So let's dive into what a context window actually is. So the context window is a maximum number of tokens a model can see at one time. It determines how much text the model can consider when generating a response. So if your input plus the expected output exceeds the context window, the model cannot access the older tokens. This means it might forget earlier part of the context. For example, GPT-4 model comes in versions with 8,000 token and 32,000 token context windows. A 32,000 token window can roughly handle 20 to 25,000 words, enough to process long document or multi-turn conversations. And understanding tokens and context window is essential because it helps you structure prompts efficiently and avoid cutting off important information and manage cost while working with LLMs. Now that we know what tokens and context windows are, let's look at some of practical implications for building LLM applications. First, we always try to keep our prompts concise. So shorter prompts are more efficient, they use fewer tokens and reduce computation cost. Second, when working with large documents, it's a good idea to split the content into smaller chunks. This allows the model to process each part effectively without exceeding its context window. And LLMs cannot remember text beyond their context window unless you use some memory augmentation features. That means they can forget earlier part of a conversation or document if it's too long. And this is especially important in applications like retrieval augmented generation or RAG. In RAG, you feed the model relevant chunk of text from your document so it can provide accurate answers without needing to see the entire document at once. So by understanding the token and context windows, you can design more efficient prompts, manage long text, and even build smarter LLM applications. Now that we've covered tokens and context windows, let's move to understanding the difference between the LLMs and chat model, which is a crucial concept for building effective AI applications. First of all, what is a language model or LLM? A large language model is trained on massive text dataset to predict the next token in a sequence. So essentially, it learns patterns in language so it can generate coherent text, answer questions, summarize content, translate languages, and even more. Some popular examples of such large language models include GPT-3, Llama 2, Falcon, and Mistral model. The key feature of LLM is that they are general purpose models, and with the right prompt, they can handle a wide range of tasks, but they don't inherently understand conversation structure or roles. Now, let's look at chat models. A chat model is essentially an LLM that has been fine tuned for conversation context. It is trained on dialogues with specific roles like system, user, and AI, so it knows how to respond in a coherent, context aware manner across multiple turns. Example of chat model includes ChatGPT and Gemini Chat and also Llama 2 Chat. The key feature of chat models is that they are optimized for interactive multi-turn conversations. They can remember the flow of a dialogue, understand roles, and produce more natural conversational responses than a standard LLM. Understanding the difference between a LLM and chat optimized model helps you choose the right model depending on whether your application requires a single turn text generation or multi turn conversational AI. So, to summarize the difference between LLMs and chat models, here's a quick comparison. In terms of training, first, LLMs are trained on general text dataset while chat models are trained on dialogue dataset with reinforcement learning from human feedback or RLHF. LLMs are ideal for cases like text generation, summarization, and translation, while chat models excels at conversational AI and agentic applications. The input to an LLM is a plain prompt, while the chat model expects a structured message including system, user, and AI roles. And in terms of output, LLM produce a single text block while chat models generate coherent multi-turn responses that maintain the conversational flow. In terms of context handling, LLMs only see the current prompt while chat models naturally maintain context across multiple turns. And finally, there are examples which we have already talked earlier. So in short, LLMs are used for single turn tasks while chat models are used for multi-turn interactive applications. Let's look at a concrete example to understand the difference between a base LLM and a chat model. So, in case of base LLM, if we give a single prompt like explain how a black hole forms in simple terms, the model might respond a black hole forms when a massive star collapses under its own gravity, and so on. Notice that the response is direct and informative, but it does not have a conversational tone. Now, using a chat model, we structure our input as messages. So you see that we have a system message saying you are a friendly AI tutor, and then you have a user message saying explain black hole in simple terms. So the output here is sure, imagine a star so heavy that its gravity pulls and then and so on. Here, the chat model output seems more conversational, role aware, and friendly. It responds according to the system instructions, making it ideal for interactive applications. So, when do we use LLMs and chat models? We use LLMs for general text generation, summarization, translation, or code generation. And then we use chat models when we need chatbots, multi-turn dialogue, personal assistant, and agent that require structured conversations. The key advantage of chat model is that they understand and maintain roles, system, user, and AI, which is essential for building agentic applications or any system that requires coherent multi-turn interactions. Now let's dive into prompts, another key concept for building LLM applications. So a prompt is basically the input text or message you give into an LLM or chat models to generate the response. In chat app-based applications, prompts are often structured as messages with specific roles, which helps the model understand context and respond appropriately. There are three main roles to know. The first is a system message or the system. So the system message defines the AI's behavior, personality, or rules. For example, if you say you are a friendly tutor that explains complex topics simply, you are explaining the AI's behavior or rules, upon which you'll add some more questions and then send it to the bot or the model. The second is the user message. The user message is where you provide instructions, questions, or requests on top of your system message. So, for example, if I say you are a friendly tutor that explains complex topics simply as a system message, now in terms of user message, I'm going to provide explain quantum physics in simple terms. And then the third is the AI message. The AI message represents the model's previous response. It is used to maintain context in multi-turn conversation. So, for example, when asked explain quantum physics in simple terms, maybe the model starts responding quantum physics studies the behavior of particles dot 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 and so on. So, by clearly structuring your prompts using these roles, you can control the AI's tone, maintain conversation flow, and handle multi-turn conversations much more effectively. We will look at a practical example of a multi-turn chat to understand how system, user, and AI messages work together. So consider this chat history here, where we have a system message saying you are a friendly AI tutor. You have a user message asking to explain black holes in simple terms. So we have an AI message giving us or explaining what a black hole is. And then we have a user message saying, can you give an analogy for kids here? So when the AI generates its response after this particular chat history, it might say, sure, imagine a whirlpool in the ocean that pulls in everything around it. That's similar to a black hole in space. So here's what's happening in this example. The system message is setting the AI's tone and behavior. In this case, it ensures the AI responds in a friendly teaching style. User message provides instructions or questions. They guide what the AI should respond to next. And AI messages store previous responses, allowing the model to maintain context across multiple turns. This structure is essential for building chatbots, tutoring systems, or any other conversational AI that needs to handle long, coherent dialogues. And by using system, user, and AI messages effectively, you can create AI applications that feel natural, responsive, and context aware. So at the end, we'll quickly go over some best practices for creating effective prompts in LLM applications. First, we always define our system instructions very clearly. This sets the AI tone, behavior, and the rules it should follow throughout the conversation. Next, we make sure our user messages are specific and concise. Clear instructions helps the AI generate accurate and relevant responses without confusion. In case of multi-turn conversation, it's important to store AI messages so the model can maintain context across multiple interactions. This allows chat models to interact or to respond coherently even in long dialogues. And additionally, keeping prompts concise helps the model stay within the context window limits, preventing older messages from being forgotten and avoiding overloading the AI. So by following these best practices, you can ensure that your chat models remain coherent, context aware, and efficient, which is critical for building professional AI applications. And finally, let's talk about structured output, often called the JSON mode, which is a powerful way to make AI responses easier to work within applications. So, what are structured outputs here? Structured outputs are responses formatted in a predictable, consistent way, usually as JSON instead of free-form text. Why is this useful? Because it makes responses easier to parse, validate, and use programmatically, and Structured outputs can also be directly fed into applications like database, dashboards, or other software without needing extra processing. But why use JSON mode specifically? So while LLMs naturally generate plain text, many applications require specific fields. For example, you might need a book's title, author, and publication year in separate fields. By using JSON mode, the AI has a consistent structure, making it predictable. It reduces errors when extracting data and makes downstream automation smoother. Using structured output is especially important when building apps that rely on accurate, machine readable data like forms, APIs, or multi step AI workflows. Let us look at a practical example of structured output to understand why this approach is so useful. Let's consider a use case where we extract book information from AI. Suppose we ask the AI to provide the details of the book Harry Potter in JSON format with keys title, author, and published year. The AI might respond with a structured JSON output like this: a title, author, and published year, all in a JSON format. If you compare this with a free-form text output like this one, you can notice the few differences here. Structured output here is much easier for programs to read and use directly, and free-form text would require parsing to extract the relevant information, which adds complexity and potential errors. So now, how to use structured outputs in LLM apps? So to work effectively with structured outputs, you can ask the model to strictly follow a JSON schema, and you can validate output using JSON parsers before using them in your application. And structured output are particularly useful for databases, forms, API responses, and multi-step workflows. For example, in Python, we can easily extract a certain value from a certain key if the key and value are in a JSON format here. In this particular example, we have easily extracted the author from the book data variable that contains the AI response JSON as given here, and then we can easily output the author name or the name JK Rowling here. Okay, so there are some best practices for structured outputs here. So how do we do that? First of all, we define a clear schema for our AI outputs. Then we try to include mandatory fields in the instruction to ensure consistent responses. Then we validate outputs programmatically before using them in the app. And for complex workflows, we combine structured output with multi-turn conversation to maintain context and accuracy. So using structured output effectively allows us to build robust, reliable LLM applications that can automate tasks, integrate with systems, and handle data programmatically. And that wraps up episode 3 of our LangChain Masterclass. In this video, we covered the fundamental of LLM applications, including tokens and context windows, which helped us in understanding how models read and process text. We also understood chat models versus LLMs, base LLMs, understanding when to use which for our applications. We also looked at prompts with system, user, and AI messages, and also structured output in JSON mode. These are the core concepts you need to build efficient, context-aware, and reliable LLM applications. In the upcoming videos, we'll deep dive into further complex concepts in case of LangChain. So if you found this video helpful, make sure to like, subscribe, and hit the bell icon so you don't miss any part of the LangChain Masterclass series. Thanks for watching, and I will see you in episode 4.